What's out there, geometers? Hope you're doing well. This video, I'm going to introduce the idea of angles of a polygon. So, the first thing we probably want to think about is what the heck is a polygon? So, polygon is, and I'll give you some examples first: a rectangle, square, trapezoid, triangle, decagon, octagon, nanogon, hexagon, chuckagon. You feel that, Chuck? Good. So polygons are really closed figures made up of line segments. And we're going to really talk about convex polygons, technically. And they have n sides, right? So n is the number of sides. So this polygon that I just created has 1, 2, 3, 4, 5. So that has 5 sides. So we call that a pentagon, right? And if there are n sides, there are also n angles, right? 1, 2, 3, 4, 5, right? So the sides and angles are the same. So if it has 5 sides, it has to have 5 angles. Make sense? Now, there's a what's called an interior angle and exterior angle. So just like we talked about with the triangle, that's called an interior angle. And if we extend any of the sides, we create what's called the exterior angle. And we can do that at each vertex of the polygon, right? So we're talking about polygons with interior and exterior angles. You'll note that both interior and exterior pairings add up to be, that's right, Chuck, 180 degrees. And that will be the case at any interior-exterior pairing. Right here, interior, exterior, etc., etc. Interior, exterior, right? We have a bunch of linear pairs, right? And so, of course, if there are n or 5 interior angles, there are the same number n exterior angles. Okay? So this is what we're talking about today. We're talking about angles of a polygon, and a polygon is a closed figure made up of a finite number of sides, segments. And if there are 5 sides, there are 5, 1, 2, 3, 4, 5 angles, right? Same number of sides, same number of angles. Okay? So here's the deal. Let's create a little chart. And I want to think today about sums of angles. So what do all the angles add up to be? Okay? So I'm going to put here, and this is going to be the number of sides, n sides, right? Or angles. And this is going to be the sum of the interior angles. Right? So I'm going to create a little chart and see if we can make some sense of this. So, we can't have a polygon with anything less than 3 sides, so we'll start with 3. All right? So if I have 3 sides, we know that is a triangle, right? That's right, Chuck. So, what are the sum of the interior angles of any triangle? Yep, that's right, 180 degrees, right? We've already done that. So if there are 3 sides, the interior angles add up to be 180. Okay? So let's move on. So that's 3 sides. What about 4 sides? So if I have 4 sides, what are the sum of all the interior angles going to be? So I'm going to create a quadrilateral, right, with 4 sides. We call it a quadrilateral. And it doesn't have to be a nice one in particular. Just any old 4-sided polygon will do. Get rid of that. And what I want to figure out is what the heck these angles 1, 2, 3, 4 add up to be. 1, oops, nope, oh, hey now, here we go, 2, and 3, and 4. And there's a clever little trick to do that. Now check this out, ready? I'm going to create, from that quadrilateral, I'm going to create 2 triangles. See what I did there? 1, 2, just with one diagonal. And each triangle has how many degrees? Yep, 180. So that plus that plus that is 180. And then this angle plus this angle plus this angle is also 180. So if I add up those 180 and 180, I get, that's right, 360. So if I take away this diagonal, which allowed me to cut the quadrilateral into 2 triangles, each triangle which has 180 degrees, then angle 1 plus 2 plus 3 is 180. Right? Because I can cut up into two 180-degree containing triangles. Well, what about 5? A polygon has 5 sides. We call that pentagon. Right? Call that a pentagon. And I'll create the 5 sides. 1, 2, 3, 4, 5. And I'm going to think about this in the same way I thought about the quadrilateral. 1, 2, of course there are going to be 5 angles. 3, 4, and 5. So what do those 5 angles add up to be? The sum of the interior angles. Well, for this 5-sided polygon, pentagon, I'm going to cut it up into 1, 2, 3, that's right, triangles. 1, 2, 3. Now each triangle has, that's 180 degrees there, that's another 180 degrees there, and that's a third 180 degrees there. Right, so really what I have is 3 180 degrees, which is 3 times 180 is 140. Okay. So what we have here is what we're establishing is a pattern. Okay. So if I have 6 sides, what would you say the sum of the interior angles would be? No. Okay, yeah, okay, that's a good idea. Let's draw one. Right, so let's move this quadrilateral out of the way. You get out of the way, man. And let's create a hexagon that's 6 sides. 1, 2, 3, 4, 5, and 6. Well, just as we have done with the other ones, we're going to cut it up into a number of triangles, right? How many triangles? 1, 2, 3, 4. Ooh. So a 6-sided polygon, which we call a hexagon, gets cut up into 4 triangles. 1, 2, 3, and 4. So, ooh, each triangle has 180 degrees, right? So 180 there, 180 here, 180 here, and then a fourth 180 here. And that counts for all the angles of that hexagon. So a hexagon would have 4 triangles times 180 degrees each, which is 4 times 180, 720. So there's definitely a pattern emerging. So what happens if there are n sides? What's going on here? Well, if I have n sides, what I do is I split that up into 2 less than n, n minus 2 triangles, right? And each of those n minus 2 triangles has 180 degrees, right? So if I have a 6-sided polygon hexagon, there are 4 triangles. 6 minus 2 is 4, each of which has 180 degrees. If I have a 5-sided polygon pentagon, there are 5 minus 2 rather, which is 3 triangles, each of which has 180 degrees. Okay? So here's what we just created. If I get rid of this stuff, let me try to sum of the interior angles for any convex, we're talking about convex polygons with n sides, right? N is the number of sides, is 2 less than n times 180 degrees. That's a times right there. Okay, so that's the one formula I want you to understand so that we can use it tomorrow. All right, the sum of the interior angles of a polygon with n sides. So here are a couple problems to think about now. Number 1. Let's get out to the next page. Number 1. What do all 12 angles of a convex, that's called a dodecagon, 12-sided polygon, add up to? Okay, and of course we're talking about the interior angles. Right? And number 2, what if all 12 angles of the dodecagon, 12-sided, are the same? what is one of the angles? Really, what is the measure? Remember, there are 12 angles, but I'm asking what's one of them, right? So I want you to think about, I can get the sum of all those 12 angles. And then, well, if they're all the same, then what's the measure of one of them? Okay? That's what I want you to think about for tomorrow. Have a good night / morning / day whenever you happen to see this. Chuck, catch you later.